really appreciate you taking time out of your day at this conference to attend our presentation that's titled Measuring Perceptions of Welcome and Approachability in Discrete versus Conspicuous Security Features Within Urban Public Space. I'm Alex Donahue, University of Maryland, and a senior associate at Michael Graves.
I'm Hernan Rosas, PhD student at the University of Maryland, and our third colleague, Alexander Slavdas, a neuroscientist who's based out of Italy.
We started this study by asking ourselves what makes a public space welcoming. I mean, you can all think of a public space that works really well, that's filled with people, very popular, but I'm sure you can all also imagine public space that's rather dead and doesn't work at all, and it sort of repels people. So thinking about that and thinking about our current context that we're in, where people are increasingly connected in a digital way, but physically more isolated, and how that affects people's well-being and the ability to interact, thinking about that, comparing that with the value of public space, is an important feature. In this photo, Hernan and I took a few days ago here on Argyle Street in Halifax. So we walked around and just sort of, you may be familiar with it. We spent quite a bit of time here and found it had some qualities that were quite engaging and comfortable. And in contrast, we took this photo also in Halifax of a self-identifying hostile architecture, which I like with the spikes here, just a few blocks away from Argyle Street, and really speaks to what we wanted to get out of this research and ask the inverse of our first question: what makes a public space unwelcoming? And in the context of living in Washington, D.C., we're surrounded by security features, bollards, fences, that are a necessity, but often feel added onto the public space. And so asking that question, is there, what's the impact of security features on personal perceptions of welcome? And to take this a step further, we looked at 3 public spaces in Washington, D.C. that are quite similar to each other, and added, photoshopped in different security features, both this, what we define as conspicuous and discrete. So the first image is of what we call a conspicuous bollard, a bollard that looks like a bollard. The second is a discrete bollard, where the bollard's been planted into the planter. So it may not read like a security feature, but still has that security function, the footer and everything that kind of makes it a secure feature. And then conspicuous cameras, surveillance poles, etc. And it's quite interesting. We couldn't have done this study the way we did a few years ago. We used AI-enabled tools in Photoshop. And Hernan's going to speak a little bit about kind of our workflow.
Yeah, so we wanted to make sure that we had selected constraints for how we selected these features. So we wanted to select features that were either black or gray, and that were weathered, so they actually looked like they belonged in that space. Generative AI does a good job at actually incorporating that into the features. And we reviewed no more than 15 options per prompt, so we allowed the AI to generate no more than 15 options and then selected from those ones.
It was fascinating because we were trying to be very rigorous about the consistency of the inputs. The words that we used were pretty much the same verbatim throughout each site.
And so I'll talk a little bit about the actual studies. So we used the platform iMotions, and iMotions is a biometric research company that facilitates online eye tracking studies. And so what this enables us to do is to create stimuli that we can present to individuals, and it gets packaged into a link. And so this link gets sent out, and anybody can do this eye tracking study as long as they have a laptop with a web camera. And so what the software does is it utilizes the web camera to track the gaze pattern of the participant who is looking at the images on the screen. And so what you're looking at here is like a gaze path, starting from where they looked at first, and then where they fixated on next, and next. And so it also measures how long people are fixating on certain spots, and the difference between a gaze and a fixation is that a fixation is just a longer gaze, at least 100 milliseconds or more. And so for the survey, it was a 5-minute study because we wanted to keep it short, 8 seconds per image. That's usually enough for eye tracking. And surveys were done for each individual image. And so the survey question that we selected to measure welcoming first defined welcoming as the quality of being open, safe, inviting for all people to enter. And so we asked for each individual question, how welcoming do you perceive this public space to be? And we showed the individual public spaces with the different security features added onto them.
And so our hypothesis at the beginning is that the integrated security features would score higher than the conspicuous, more blatant security features. And so that was like pretty interesting. You'll see kind of a big reveal here in a moment of the results. But kind of a little bit more about the methodology. Hernan and I went on a cold March morning to Washington, D.C. to these different sites, trying to find, at least a partly cloudy, nice enough day to get consistent photos. We were pretty rigorous in our methodology for the photo taking, which was very important for the eye tracking software, which Alexander Rosas, who's not with us, specializes in kind of understanding this and really helped us gauge. So we took photos from each park on the south side of the park looking north to avoid glare from the sun, and tried to keep a pretty consistent solar orientation per photo. We also tried to find the primary path into the park and follow that path about 20 feet into the park and look north and try to look towards a central focal point. And that's kind of what you're seeing here. Sun can't control that totally, and I think there is probably something we learned from this is color and saturation really do have somewhat probably an impact here that we would want to address in our further study. And then also orientation, making sure the angle is looking straight ahead. The natural terrain is an aspect as well that is a factor to kind of think about. So big reveal, kind of the welcome score within these spaces, kind of introduce this in phases, but this is our control photos. These are the 3 photos we took, and relatively high. It's actually the highest welcome score out of any of the photos that we had, and you can see that site 3, Franklin Park, had the highest 4.5 out of 7, and the lowest is site 1, which we're speculating might have to do with the slight kind of differences in light and other factors. But kind of keep those numbers in mind, roughly 4.65 to 4.98.
And so being that this is an eye tracking study, the software is able to generate heat maps. So what you're looking at here is concentration of gaze and duration of each individual image shown for the control group. So the areas in green show a small amount of gaze. Areas in yellow and red show higher amounts of gaze duration.
And that's something that we might, for the next study is not pick like these 1-point perspectives, these forced views down to the horizon line, because we're seeing there's a lot of concentration at that focal point that's not really relevant to our study. So the welcome score for the conspicuous bollards, and you can kind of see our photoshopped images here, are markedly lower than the control, and actually the lowest score that you're going to see today. And what's interesting is site 3 had the highest welcome score for the control, but now has the lowest with the introduction of the bollards.
And so now overlaying the heat maps on these images, you can see that with the introduction of the bollards, there is some general avoidance of the bollards. So the gaze is kind of going around the bollards in the first site for McPherson Square. But in the other ones, the gaze does seem to fall over bollards to some extent.
We find that particularly interesting in one, like people are actively avoiding looking at the bollards. And the welcome score for the discrete bollards, so these are, again, the bollards with planters integrated into them that would have a similar security impact as the conspicuous bollards, scored a lot higher, almost very similar to what we saw in the control, just slightly lower on average overall, ranging from 4.35 to 4.88. And you can kind of see, we tried to vary some of the plantings, but we tried to keep it pretty consistent. And that was an interesting aspect of using AI-generated images, is you don't have complete control over what AI spits out. So you can only control the text and the prompt, and then select kind of a similar image. So that's something that we want to refine for the next study, because you can notice there's some kind of differences, subtle differences in saturation and color in the plants and the amount of plants versus the planter itself. And
so the gaze now is a little bit more selective and biased towards the plants, especially the site 1 McPherson Square that had a little bit more plants in it. And what you're, the numbers that you're looking at down here, we also were able to calculate like how many times the gaze entered in these particular areas, and how long those fixations lasted in those particular areas, just looking at the planter itself.
And so our last feature, the conspicuous cameras on poles kind of throughout the park, scored lower than the discrete bollard planter combination, but higher than the conspicuous bollards. And we thought this was quite interesting, kind of probably higher than we expected, and potentially one thing that we'd want to revisit is, does the orientation and location of these camera poles impact the score? They're not front and center in the foreground like the bollards. Maybe there's something to that. The general area of interest is smaller, so the part that the eye tracking software measures is a smaller area than the planters. So, that's something interesting that we're going to have to think about moving forward.
And so, looking at the heat maps, though, these cameras are generating a lot of the attraction for the gaze. You can see the concentrations of red pinpointed around the camera itself, not necessarily the pole, but the actual camera itself.
And so to kind of summarize what we've discussed today, again, the control image, the base image with no security features, ranked the highest average of welcome score. The discrete bollard planters were second, and then you can see a consistently lower score for both conspicuous security features, and that aligns with our hypothesis at the beginning.
And so summaries for the fixation counts. The planters generated more fixations than did the bollards or the cameras, and we believe that this is due to the attraction to biophilia. There's more fixations that would go back and back and back to the planters, whereas that did not happen for the bollards or the cameras. The cameras did receive the lowest amounts of fixations, but that could also be because of where they were placed on the image. They were not front and center like the bollards and the planters were. And so this is looking at average fixation dwell time. So this is like total amount of time that an individual was fixated on the particular area of interest. And so you can see that the conspicuous bollards received the lowest amount of fixation time. So they were generally ignored and looked around.
Which is fascinating because it still appeared on the welcome score that people found those images to be unwelcoming, but they weren't looking at the bollards directly. And
so fixation duration is on average, when someone fixated on the area of interest, how long was that fixation? So it's not a total, it's just an average of each individual of individual fixations. And so the cameras received the highest amounts of average fixations. But what's interesting is that if you remember a couple slides back, the cameras also received the lowest amount of fixation counts. So it's just that people would look at the cameras maybe once or twice for a long time, potentially trying to understand what it is and why it's there, but did not go back to it, so they weren't returned to.
So coming to a conclusion here, we found in this pilot study, and this is a pilot study, and we'll get into the limitations here in a second, but we found a connection between the welcome score and more fixation, the count of fixation, as well as longer fixation dwell times, but we did not find that the fixation duration coincided with welcome score. So that was sort of interesting that we need to kind of understand better before we develop this into a further study. We cannot reach a definitive conclusion, but based on a pilot study, we found that the initial findings supported our hypothesis that the discrete bollards would feature a higher welcome score than the conspicuous features. And what could this mean? What's the significance of this for designers and people that want to implement security features within the public realm? Based on this initial research, since the security features were perceived as more welcoming when they were integrated into planters, designers should consider the holistic integration of these features in public space and a potential focus on biophilic elements. So that's definitely something for further study, is perhaps comparing different types of integrated security features and not just make the conclusion that every integrated feature would be the same. And I think, for further study also, expanding the number of security features that we would show in the study.
And it's important to note that there's many limitations to this kind of study. Most importantly, the limited sample size. So there were 18 respondents for this. It was also through convenience sampling, so we had to basically ask people to take this survey and see whether people would actually do it. The area of interest also varied, so the images that you're looking at on the screen are the areas of interest. So those are like hand drawn around the particular area you want to analyze, which the software allows you to do for any object on there that you'd like to understand. And so also the cameras, like in the top image, they weren't centrally placed, so that could impact how people perceived it, because maybe they were fixated just on looking straight ahead, and then it took a long time to actually look at the cameras.
We did ask a demographic survey at the end and found a pretty wide range in age, the oldest being over 80 and the youngest being in their 20s, and found a healthy split between gender and racial background. But with 18 respondents, it's limited meaning. But it's exciting if we, our goal is really to expand this to a much larger sample size, and that's something we'd be really curious to understand is how do the responses change based on who's responding to the survey.
And so we're looking to conduct a more intensive study in the coming months. We'd like to open up this survey to more people, a broad audience, maybe a little bit longer, look at different features, and
we are looking for funding opportunities to conduct this study. So if you know anyone, let us know.
Yes, definitely.
And we welcome any feedback this time of the presentation. Since it is a pilot study, it's actually kind of the perfect time to present something like this to get feedback. So we welcome kind of questions, but also constructive ideas of how we could improve the study for a much larger effort. Thank you.
I have a question about, can you go back to the 3 picture of the beginning, the 3 parks? I wonder, did you control each element's proportion of the overall image? For example, if they have the similar percentage of the gradient or